Welcome. Today we're going to be reviewing some of the capabilities of HarperDB's multi-tiered cache system with context of server-side rendering through multiple different front-end frameworks such as React, Svelte, Vue, and Solid. We're going to mainly focus on React, and then we'll kind of dip over into the other frameworks code just to demonstrate that they all kind of can achieve the same things with some similar solutions. To get started here, the HarperDB React SSR example will be linked in the video description, so please check that out if you haven't already. In this repo, you'll see some getting started instructions. You're going to need HarperDB already installed on your system. Beyond that, it's a pretty simple HarperDB application. It has a single table exported called post, which has what you might expect, an ID for the post, a title, a body, and then a list of comments. It also has a cache table, which is going to kind of be the underpinning for the blog application we're going to build with React.js. The post itself is instantiated at the very beginning of the application. So if you don't have a post table already in your HarperDB app, this will kind of generate a test, some test content for you. We can get started here by running HarperDB in the root of this project directory. And then in another browser window, we can curl the post endpoint and see if we get something back. So we have a post and there's no comments. Now, jumping into the application is on the right-hand side. Here we're looking at the uncached blog page. So we refresh it. You can see that this page is a 200 for the code itself. And it's a fully interactive React app. So we can add comments and we can submit them. They get updated. We can delete those comments. We can add more comments, even more, multiple at the same time, remove old ones. And you can see that there are a bunch of operations happening in the background here. The page itself is built on a WebSocket connection to the post. So the data is live reloading as you modify it. The modifications themselves are happening through some fetch requests because this is all client side. And so we're just for now using some basic patch operations to modify the comments of this post. And now that we have a comment here, we can go over to our terminal, we can curl that post and you can see it's propagated here. So it's also not just happening on the client side. But now how all of this works is clearly this is a React page. Export default function post from app.jsx, and it has the initial post data. You use that to set that initial state. This use effect will kind of hook onto that WebSocket connection to create the live reload effect. And then everything is rendered quite simply below. In order to build this page, we have to provide it that initial post data. And this is where HarperDB's resource API and multi-tier caching all comes together. So over here on this side of the page, we'll kind of scroll down. Looking at this exported uncached blog class, this is a HarperDB pattern called resources. So uncached blog is a resource because it implements the get method. And it's extending from the post table, which also in itself is a resource, but more specifically, it's a table resource. So this table has a lot of stuff happening behind the scenes, and it's what you would expect in a database application. You can add posts to the table, you can remove posts from the table, you can modify the records in the table, which is what we're doing in our application. But coming back out a layer, when you derive a resource in HarperDB from another resource, it develops a relationship. And so here, async get, and we return status 200 with the text HTML headers and a body of await render post with this. The this keyword in this class instance is going to be whatever post you're selecting. So here we're selecting the 0th post. That is getting passed through to this getter function. And so we're going to render that post. Here we can see, if we jump back over to this, that we have a console.log rendering post 0. So here in our render post function, that post object is coming through in the shape that we expect it to. And right here, we're using that renderer. So we're calling the render method of our React app with the post data. The rest of this stuff is kind of how you get the SSR to work and have the site remain fully reactive, because once you build it on the server and it's delivered to the client, React needs to what's called hydrate the page. And so we need to make sure that the client and the server both build the same thing to start. And then once that initial load happens, the client can run off and do whatever it wants. And that's kind of what we see here. The initial pages are the same, but then as you add comments, things change. The way this works is we are using a popular front-end build tool called Vite. And if we run npm run build, you'll see that a bunch of stuff is happening behind the scenes. This is running two different build commands, build client and build server. The client builds first, and it will generate a index.html along with some assets. This asset is like the bundled React code, which will rehydrate the page. But then on the server side, we really only care about this entry server.js. And this is how, leveraging this function is how we are going to get our renderer to work on the server side and unlock server-side rendering. But where this really starts to show its magic is with the cache table I showed off at the very beginning of the walkthrough. So this blog cache, this is another HarperDB feature, has a lot of caching heuristics baked into it. It has an ID, but it also has a single property content. So in the resources, we start off by creating this class. It's not exported, but it is extending from tables post, just like uncached blog was. So it is, again, it's a resource. This resource has its own get method, and it returns that single property content, which again is coming from the render post method. We source our blog cache table from this builder, and then we create one more resource, cache blog, which extends from the cache table. And this will simply return the content that was generated by the page builder, and we'll set the content type to HTML so that it renders correctly on the browser. So if we go over to this other tab, we'll see that this is the cached blog endpoint, which is automatically generated by the name of the resource. And if we refresh the page, we're not running HarperDB anymore. So let's do that again. HarperDB run on this example. We'll refresh the page, and ideally it will work. Wonderful. So now we have our we have our blog post again. You'll see on this very first load, we get a 200 because the operation still needs to happen at least once. But if we refresh the page, this blue tile, gets a 304. And we don't see another rendering post logged in the terminal of the HarperDB server. If we jump back over to the uncached blog and we refresh this page once, twice, 3 times, you'll see that it's re-rendering on the server every single time. But on the cache blog example, when you refresh over and over and over again, it keeps getting the cached data. And this cached blog works exactly like the uncached one. It's fully reactive, so we can add more comments, hello, goodbye. We can modify them in place, and everything works as expected. And now let's demonstrate a little bit of the magic of React here. So if we refresh this browser on the left-hand side, we can pretend this is like a second client. Someone else is connected to this endpoint. Since it's using that WebSocket connection, if you add a comment over here, you'll see it over on this side as well. And you can see the reactivity is almost instantaneous. This is also powered by HarperDB. The content, the post data that our page is built on, again, that WebSocket connection provides a live view of that record. And so your page can be very, very reactive. And that's just React, however you want to build your application. To further demonstrate the caching behavior here and that it's not client specific, let's go on the left-hand side and let's refresh this page. We'll see that we get a 200 because there were some new comments that we just modified. If we refresh the page on the left one more time, you'll see it gets a 304. On the right-hand side, notice that we haven't refreshed the page yet since we've done the rendering on the from the left-hand side. When we refresh this page on the right, you'll see that even on this first new load, it is a 304, which demonstrates that there are cache hits across multiple clients. So that kind of wraps up the functional demonstration of the SSR and multi-tiered caching. And depending on what your preference of front-end framework is, we have examples built in all different popular front-end frameworks, including Svelte, and this does the exact same thing. It uses uses WebSockets to keep the live data reloading, and it has a renderer method very similar to the React one. We have Vue.js, and we have the app.view. You can see again, it's using it has the add comments, and it has the WebSocket connection down here. And then we have Solid.js as well, which uses JSX. So this looks a lot like the React example, but it's a little bit different. And again, all of these renderer methods are inside of that resources.js. Before we kind of end this walkthrough, I wanted to highlight another script that exists in these example repos. So this is the caching test script. And we'll kind of run through this. I did this demonstration live with the browser windows, but in case if you wanted to kind of dive a little bit deeper into the HTTP logic that happens behind the scenes, you can review this file. So starting from the top, we have two URLs. We have the blog URL, which is the cache blog endpoint, and we also have the post URL, which is the raw post data. We start by fetching the blog URL. We want to check the e-tag and last modified headers. So then we store those. Then we do another load. So we load the page a second time, and we need to pass the headers from the first request. This is what your browser is doing behind the scenes. If you just made raw HTTP requests to the cached page with no caching headers, it would not know that you want the cached response. It's kind of how caching works. So then we check the status code of the response to, and we assert that we get the 304 cache hit. Then we want to update the post. So we're going to get the existing post data in this call, and then we're going to patch that post by assigning a random comment here. And then assert that all succeeds. And now we're going to load the page again. This is a third time, but this is the fourth request on the page. So this page will, again, you provide those headers, the e-tag and last modified, but since the record has been modified, since these header values were set, we now expect a 200 because the page is getting re-rendered. We want to store those tags one more time. We're going to do another request, and then we want to assert that that second request after the render is always going to be a 304 cache hit. So again, you can run this script and kind of modify values in here if you would rather do a little more of a code example versus the browser example. And that kind of concludes the SSR and HarperDB multi-tier caching walkthrough. Thank you very much.